Okay, hello again. Year 10 triples. This is the video to accompany the fact book for your chemistry week 4, second chemistry lesson that week, which is the week beginning the 29th of June. Looking at what we call fractional distillation. We'll get on to that more in a minute. Hope you are all still safe and well, and coping okay with obviously the slightly different end of term or final term of your year 10 before the summer. So just some quick questions about what we did in the last video. If you want to pause it and have a go at those, and then we'll go through them. Okay, number 1, what do we call the molecules found in crude oil? Well, they're called hydrocarbons because they're made up of hydrogen and carbon combined in different proportions. Number 2, which type of these molecules did we look at last lesson? The answer is alkanes. Number 3, what is the general formula for alkanes? It is CnH2n plus 2. So how many carbons a particular alkane has, it will have twice as many hydrogens in each molecule plus 2. So if it has 2 carbons atoms in the molecule, it will have twice as many, so that's 4 hydrogens plus 2, 6. So it would be 6 C2H6. Number 4, what word can we use to describe them as they only have single bonds? The word we use is saturated. We say they are saturated because there's no way of getting any more hydrogen into each molecule. All the bonds are single, so all the bonds are being used. And number 5, what is the name of the alkane with 4 carbon atoms per molecule? The answer is butane. You need to know the first 4. Okay. Moving on then, those are the facts we're covering in this video, which is to do with how we actually extract the hydrocarbons from the crude oil where we find them. Okay, so that is crude oil pretty much as we find it. We don't obviously measure it, tend to work with it in such small quantities, but that is its general appearance. It's a thick, very thick black liquid that is made up of a combination of different things. Okay, and we're going to look at how we extract the useful, what we call fractions from the crude oil, which is where the name of the process comes from. That's why it's called fractional distillation. Okay, so first a little bit about crude oil. Crude oil is formed, generally speaking, at the bottom of the sea, or where there once was sea. So tiny microscopic plants and animals die over a long period of time. A lot of that organic matter builds up at the bottom of the sea. If it is covered in sand and mud, it doesn't break down as it would normally, and eventually over a long period of time, as it gets buried deeper and deeper and deeper, it decomposes to form what we call crude oil. As that happens, some gas is also released, but we're not worrying about natural gas at the moment. We're focusing on crude oil. Okay, we get to that oil by drilling down through the sand and mud, which will have become rock, and the oil is then released and it travels back up and is then transported to wherever it needs to go for processing. So if it gets trapped in the rock or by rock, it cannot escape, so we drill down through the rock once we've figured out where it is, and we obtain the crude oil. Okay, so if you want, we can pause that and have a go at writing that process in the correct order, or picking the correct words, sorry. Okay, so it should read, crude oil is a mixture of compounds that can be separated. Oil and gas were formed from the remains of plants and animals over millions of years. When dead matter decays, it is turned by bacteria in the absence of oxygen into crude oil. As the mud layers built up, high temperature and pressure was created. This converted the material slowly into oil and gas. Earth movements caused the rock to split, and the oil and gas were trapped between the layers of non-porous rocks, which is why they were trapped. Gas and oil moves upwards through porous rock, because porous means it has holes in it, which allows that to happen. And we find oil fields under the North Sea and many other places on the earth as well. Okay, so Crude oil is the name of oil when it's first obtained from the earth. We know it's a mixture of hydrocarbons, and we know that the chain length or the size of the molecules in a hydrocarbon affects the properties of that hydrocarbon. We looked at that last lesson. We also hopefully are aware of some of these meanings. We spoke about these last lesson. Boiling point is going to be key in this lesson. That's when the temperature where a liquid turns into a gas. Viscosity is how thick or how easily something flows. And flammability is how easily something can be ignited and burned. Okay, now we get the various fractions, the hydrocarbons we want to use from crude oil using something called fractional distillation. And we're going to look at that process. So what happens is crude oil is heated until it evaporates, until it becomes gas, until all the different parts, the different fractions, become gas. It is then passed into what we call a fractionating column. In the fractionating column, there is a range of temperature. It is warm at the bottom, very warm, very hot at the bottom, all the way up to relatively cool at the top. And because of that, the different fractions change back into a liquid at different points up the fractionating tower. So the ones with higher boiling points appear, or they can be collected near the bottom of the tower. The ones with lower boiling points are collected near the top of the tower. So the crude oil is heated till all of the fractions become a gas, and then they are collected at different points up the tower as they turn back into liquids, as they condense back into liquids. And that is called fractional distillation. So, near the top, you would collect some of them as gases even, because they would be gases even at those cool temperatures. And then moving down, you collect the different fractions which can be used for different things at the different points down the column as they reach their the temperature where they condense. So the fractions you would collect near the top would be liquid petroleum gas, then petrol, some of these you'll have heard of, then naphtha, paraffin, diesel moving down the column, fuel oil that we might use in houses, lubricating oil that people use in engines and things like that, and then down near the bottom, really thick, high boiling point fractions like bitumen, which we can use to make roads. Okay, and so we see the boiling points up at the top. Well, the ones that we collect still as a gas, they boil at 25 degrees, so they have become a gas. They're still a gas, even up at the top where it's cool, all the way down to the thicker, bigger fractions at the bottom, which are boiling at 300 to 350 degrees. That's where they turn back into liquids and can be collected. Now, we spoke about the size of the molecule affecting the properties. So the small molecules are collected up near the top because they have the very low boiling points. The big molecules are collected down near the bottom because they have high boiling points. So down near the bottom, something like bitumen, it might have 120 carbons in each molecule. Big molecule. Up near the top, there might only be 2 carbons, 3 carbons, in some cases 1 carbon in each molecule of those hydrocarbons. That's why they have such low boiling points, because they're very small molecules. Okay, so again, as we spoke about, that's the process. Heat the crude oil till everything is evaporated, pass it up the fractionating column, and then at the different levels of the column and at the different temperatures, which are people know about the column, they know the temperatures at the different points, you can collect the different fractions which can then be used for these different purposes. So bottled gas that people use for wherever gas is used for cooking and things like that, petrol, and to make other things like plastics and so on, naphtha again used to make chemicals, jet fuel, diesel oil which we also use in engines, and then as we spoke about down near the bottom, fuel oil possibly for ships, things like that, lubricating oil, and the really thick, very viscous fractions that we use for road surfaces and things like that. Most of the fractions are used as fuels. Only a very small amount of them are used to make things like plastics and so on. But crude oil is a very, very useful substance to us. regardless of whatever the issues are environmentally. It's a very useful substance to us because we can get all of these different fractions which can be used for so many various different things. Okay, there is a nice little summary of it. I don't know if you want to write that down. I'll take a photo of it. Crude oil heats up and evaporates, enters the column as a gas. The fractionated column is hot at the bottom, cooler at the top. The larger hydrocarbons with the high boiling points turn back to liquids near the bottom. At the high temperatures, the smaller hydrocarbons stay as gases, and so they rise up the column and condense off at different points. That's why we can separate the crude oil into the different fractions that we need. Okay, showing it in terms of the size of the molecules. The whole mixture of the crude oil, which contains molecules of all different sizes, they pass into the fractionating column as a gas. And then as you go up the column, you get the big molecules at the bottom, smaller, and as you move up the column, the large molecules condense straight away, smaller molecules condense further up the column, and right at the top, the very smallest molecules might not even condense. They would probably be collected still as gases. But it is to do with the temperature of the column decreasing as you go up the column, and therefore they are collected by boiling point. Highest boiling points at the bottom, which are the big molecules, lowest boiling points at the top, which are the smallest molecules. Okay, that's the key point of fractional distillation. And there's another just a representation of it and showing the different properties. So the more flammable, smaller molecules collected at the top of the tower, down at the bottom, very low flammability in those big molecules that are collected at the bottom. Likewise, the very runny, in fact still gas, collected at the top, much thinner fractions nearer the top, down to the bottom, very, very thick, very viscous fractions collected at the bottom with the high boiling points. And that is because of the size of the molecules or the chain lengths. Very short chain at the top, so very low boiling points, that's why they're still gases, to very, very long chains at the bottom, very big molecules, very high boiling points. That's why they're such thick liquids. Okay, so there's the summary we looked at the beginning. Now there's a video you can watch there that summarises it as well, so by all means follow that link or use that link just to get another version of the explanation, and hopefully if there have been any parts you've been maybe unsure of, that will help with those. So you can pause it now and have a go at filling in these gaps, and then we'll go through it. Okay, so crude oil is heated until it vaporizes or evaporates. The vapor cools as it rises up the tower and condenses, which means it turns back to liquid. All the fractions have different boiling or condensation points. The larger the molecules, the higher the boiling point or condensation point, and so they condense at different levels in the fractional distillation column. Okay, so going all the way, we won't do that because we're running out of time on the video, but if you refer back to the fact book, you can see the points that we've been covering, and hopefully this little explanation has helped you with that. Okay, thank you.